Have you finished?
Yes.
All right. So now look at the exercise that we are going to do. We have 6 exercises in this file, okay? And we will do all of this in today's class. All right. You will do the exercise, and if you have any questions, all right, you can turn on your microphone and ask me. All right. Um, I will give you some times for each exercise, and then I will call somebody to answer the questions. The first one is exercise 1. Tell the difference between the following concept. Okay. You will have about okay, 5 minutes, okay, 5 to 7 minutes to think about the questions, to think about the concept, and tell the difference and call someone in the class, okay, to have me to differentiate between the concept. All right. And why you are trying to solve the problem, doing the exercise. If you have any questions, you can turn on your microphone. Okay. Now, it's exercise 1. If you don't have any questions, I'm just assume that you all know it and you all can answer the questions. Okay, time's up. And now, anyone, help me to tell the difference between the population and sample. Any volunteer? Any volunteer? Okay, I see one volunteer. Okay, Đức Mạnh nè.
That teacher, I will. Can you hear me clearly?
Yeah, I can hear you.
Okay, I think the difference between population and sample is population is a subset of entities under study, while the sample is only a subset of population.
Okay, so populations, all right, exactly. So population include all the entities of interest, okay, and sample is just a subset of a population. How many population do we have when we do a research?
Uh,
How many population do we have when we are doing a research?
I think it will have one or more.
Actually, we have one population of interest when we do a research, okay? And how many sample can we have? Can we take in? How many sample can we take from the population?
I think there are many samples when we take a research, and I think the more samples, the better the result we get.
Okay, actually, research, if we were using one sample, okay, we use one sample, but we can draw different sample. We can take different sample from one population, which means that for one population we can have various samples. Okay, all right. But if when we do the research, we use one sample, okay, to estimate the population model. You, that is for number one. Cảm ơn bạn Mạnh. Now, for questions B, what about B? Do I have? Now, questions B. Okay. Phương Thảo nè.
Can you hear me?
Yeah.
Okay, so to follow up to the first question, for the second question, it is observed data is from the population, the whole population, then it is called population regression. And if the data is from observed a sample, then it's called sample regression.
Okay. So, firstly, what is a population regression model? What is a population regression model? It is usually a principle or a rule that we use to show the dependencies of the dependent variables on the independent variables. Okay, and that rule can apply for the whole population of interest, right?
Yes.
Okay. Why the sample regression model is also a rule that show the different, so the dependencies of the dependent variables on the but that rule can apply for a specific sample only. All right. So that is the difference between the population regression model and sample regression model. And we have only one population regression model, right? And how many sample regression model can we have for one problem, for one research?
I think we can have many sample. The bigger the population is, like the more sample we can have.
So as we can take a different sample from the population, we can have accordingly many different sample regression model, right? All right. So can you help me to write down the population regression model and sample regression model of a two variable regression model? Okay.
You mean me
What
giving
about
an
the
example?
population regression model? No, just write down the form. Just write out the form of a population regression model, of a population two variable regression model. Okay, we want to write down the form of the population regression model and sample regression model. Do you remember how we write down the population regression model of a two variable regression model?
Okay, let me check my my note.
All right. And also the population regression model can be identified, can be specified if we have the data for the whole population. Okay, but
Yes.
when we have the data for a sample only, we can only specify the sample regression model. Okay. Now, what is the form of a population regression model?
I don't know. Based on my textbook.
Okay. Chỉ cần viết ra cho cô là viết cái mô hình hồi quy tổng thể, mô hình hồi quy mẫu như thế nào.
Population.
Just for two variable regression model only. Viết cho mô hình hồi quy hai biến là được rồi ạ. You have yi.
The function here it says
The function.
conditional expectation function. Am I right?
Wait a minute. Now we have
EI is equal
yi.
Beta 0 plus beta 1 multiplied by xi plus ui. Am I right?
Yeah.
Okay.
As the stochastic form of the population regression model, we also have another way to express the population regression model, that is the population regression function. Do you still remember it?
F of xi is equal delta 0 plus delta 1 multiplied by xi.
Okay, but we have in the left side, okay, in the left side of the equations, what is it?
Um, it's E, Y. I don't know how to
The
say the,
conditional, the expected value, conditional expected value of y.
yeah.
Okay,
So the condition here is X, I.
yeah, okay, based given on the value of x, okay,
Yeah, equal F,
is
X, I.
beta 0 plus beta
B,
1.
beta 1 multiplied by Xi.
Okay, right. So these are two ways that we can write down the population regression model. The first one is the stochastic form, and this show the sticker relationship between x and y, which means that for one observed value of x, we can have different value of the dependent variable y. Okay, statistical relationship between x and y in the stochastic form. For the population regression function, okay, it's so the functional relationship or the deterministic relationship between x and the condition of y, okay. All right, for the sample regression model, how can we write the sample regression model? How can we do that? The
Um,
sample regression model?
so for the sample, um, it's gonna be like the population but without UI.
So can you
Yeah, so it's gonna
change
be EI equal delta zero. I don't know how to write the
uh,
symbol above.
okay, beta 0 hat.
Hat, okay. Plus delta zero hat multiplied by xi, beta 1 hat. Okay.
That's all.
Um,
Do we have
the
any
xi also have a hat on top.
like this?
Oh no, I'm sorry, the yi.
Okay. All right. This is we call this call the sample regression function. Okay. That's so the statistical deterministic the observed value of x and the fitted value of y or the estimated value of y. We still have another way. We still have another way to write down the sample regression model. That is the stochastic form of the sample regression model. What is it?
Okay, so for the stochastic, it's gonna be yi equal
Mhm,
delta 0 with hat plus
mhm,
delta 1 with hat multiplied by xi, and then finally plus ui with a hat.
mhm. Okay, with UI hat. Okay, so this is how we write down the population regression model and the corresponding sample regression model. Okay, and the difference between them is the hat. Okay, the hat over the symbol. All right.
Yes.
Can all right. That is the difference between population regression model and sample regression model. Okay, we can identify the sample regression model when we have a sample data. Okay, but we can only identify exactly the population regression model if we have the data for the whole population. All right. Thank you. And now for question C. Know the difference between disturbance and residuals. Okay. Okay. Huyền Trang có điểm chưa?
Em có trả lời một lần rồi ạ.
Ok. Có trả lời một lần rồi thì cô sẽ gọi các bạn khác để lấy điểm nhé. Vừa rồi thì có Thảo và bạn gì nhỉ? Quên mất rồi. Trí nhớ cô hơi ngắn hạn tí. Đức Mạnh. Ok. Alright. Minh Thu.
Yes, I'm here.
Okay. So help me to differentiate between disturbance UI and residual.
Yes, the disturbance UI.
Disturbance UI.
Yes, it is.
UI and residuals.
Yes.
Residual, what is it?
Disturbance UI is represent other factors that affect the consumption.
So it represents other factors that affect what? The dependent variables, okay? Not only consumption, but for different example or different research, you will have
different UI
variables. So UI here represents other factors that affect the dependent variables. And what is the difference between disturbance and residuals?
The residual is the estimator of the disturbance.
Okay, so here the disturbance represents, right? Represents other factors that affect the dependent variable y. Okay, and residual is the
Estimator.
Okay, is estimators. Estimators of the disturbance UI. Okay, now what are the other difference?
I think the disturbance UI is the called stochastic disturbance or the error term.
Stochastic disturbance or the error term. All right.
And
yes. What else? Okay, right. So anyone who can help to men to answer these questions. Đắc Minh nè.
The parameter in the statistic.
No. The difference between disturbance and residuals. Giơ tay sớm đấy, cô đã hỏi câu sau đâu mà đã giơ tay câu sau rồi. Ok.
Em được con trả lời
Dạ.
tiếp được không?
Thu à? Thông Minh. Ok. Rồi. Đăng Minh chúng ta đợi một chút để bạn Thu Minh trả lời.
Yes.
Thôi.
I mean, the residual is the difference between the sample mean and the observed value.
The what? Can you?
The residual
Okay. The residuals. You are
is
that.
the difference
Okay.
between the sample mean and the observed value.
Nope. Between the sample mean and the observed value.
Why
You
I
can
had.
Okay, y I hat. That is the fitted value of y. Okay. So now, all right, you are right. U I hat the residual. The residual U I hat is the difference between the observed value of y and the
Y
fitted value of y. Okay.
minus.
This one.
Yes.
Given from the sample regression model. When you replace the observed value of x into the sample regression function, you will get the fitted value or the estimated value of y. Okay, and ui hat, the residuals, is the difference between the observed value of y and the fitted value of y. And what about the disturbance ui?
The disturbance UI
What's it?
is the difference between the population mean and the observed value.
What?
Is the UI disturbance UI is the difference between the population mean and the observed value.
No, no, is not the difference between the observed value.
The fitted value.
What is that? No, not fitted value. Here is the fitted value. We call yi hat the fitted value or the estimated value of y. Okay, but what is the different? What is ui here? The disturbance ui. What is it?
Is
The difference between what? Okay. Now, look at your note. Look at your note.
yes.
What is the disturbance ui? What is it? It is the difference between what?
I mean the expected value of y.
Oh, okay. You can say that is the difference between the observed value of y and the conditional expected value. Okay, the value of y. Okay, see that? It is called the conditional expected value. Expected value of y. Okay.
Yes.
The expected value of y conditional on x. Okay, is also it. And this WI is the difference between these two. All right. That is the second difference.
Then I I think that one more is the disturbance are independent.
Okay, independent. Independent of what? Independent of what?
They are independent of
Now, can we calculate the exact value of the disturbance?
no, we cannot, because it is error term. I know some example.
Okay, we cannot calculate the exact value of the disturbance UI because we do not know the conditional expected. Okay, we can see the observed value of y here, but we cannot calculate or we cannot identify the conditional expected value of y. Okay, and that is why we cannot calculate the exact value of ui hat. And what about the residuals? Can we calculate the value of the residuals?
Yes,
Yeah.
we can calculate it.
Yeah, it can be calculated using sample data. Okay, we can calculate the based on the value of x. Just plug in the value of x into the sample regression model. Then we will get the fitted value of y, and we take the observed value of y minus the fitted value of y. Then we will get the exact value of the residual ui hat. Okay.
Yes.
All right. So that are the difference between the disturbance UI and the residual.
Yes.
Do you find any other difference, guys? Do you see any other difference that that we do not mention here?
In my notebook, it writes something along the line of the sum. The sum of residual.
Repeat it. I'm not. The sum of what?
Residual is 0.
Ah,
And the sum of disturbance is not.
Okay. So actually we still have do you remember this one? We have the third assumptions of the classical linear regression model. Conditional expected value of of ui given on the observed value of x that is equal to 0. And this also means that the sum of ui will be equal to 0, right? That is our third assumptions of the classical linear regression model. We do have the sum of all disturbance equal to 0, and also we have the of ui hat is also equal to 0. Is this đúng không?
Yes.
Yeah. Do we have any other difference between the disturbance ui and ui hat? Có cái nào khác không ạ? Mà cô không nhớ ra không? Chắc là hết rồi nhỉ? Okay, so the disturbance UI.
Well, hold on. I want to ask whether
in the popular. Yeah.
Is disturbance correlate to xi or yi?
Correlate. Oh.
Yeah.
Oh, okay. based on the second assumption, that is our x variables are what as non-stochastic. Okay, the x variable, the independent variables are non-stochastic, or we can say that they are fixed variables. Okay, and then we will not have the correlation between the disturbance UI and the independent variables. Okay, there's no correlation between them.
Thank you.
I will appear, okay, here in the population regression model, okay, the stochastic form of the population regression model, and the residual UI hat will appear in the stochastic form of the sample regression model. Okay. All right. So that are the difference between the disturbance UI. Okay, thank you. Thank you too. And what about the difference between parameters and statistic, population parameters and sample statistic? What are the difference between them? Okay. Đắc Minh nè.
Okay, so the difference between parameter and statistics is that parameter is using to describe for a whole population, while statistic is only describing for a sample. And between statistic and parameter, there's a few like still be likely in some ways, like for the statistics, the population will be pH, or where in a population parameter, the proportion will be P, the mean will be X bar and mu, and the standard deviation will be S and sigma, and also the variance will be S square and sigma square.
Okay, now từ H point, từ mỗi ý một câu thôi ạ. All right. What is the first difference between population parameter and sample statistic?
The first is parameters is used for a whole population, while the statistic is only used for a sample.
That is the characteristic. Okay, this is the characteristic of the whole population. And sample statistics show the characteristic of a certain characteristic of a certain sample. All right. What else? Can we calculate the exact value of the population parameters?
No, because due to the source of data and the number of data we have to calculate is to calculate the population parameter. If we don't have enough data.
Okay, so we can only calculate the exact value of the population parameters if we data for the whole population of interest. Okay, so usually in practice we do not have the data for the whole population. That's why the population parameters cannot be
calculated.
Yeah, it cannot be determined hoặc là calculated. Exactly. Okay, it cannot be calculated exactly. And what about the sample statistic?
Because the source of data is quite small, so we can calculate exactly the value of sample statistic.
Yeah, for the sample statistic, because we have the sample data in hand, so we can calculate the exact value of this. Okay, so is population parameters a constant or a variables?
The population parameters is not a constant. Like we can only estimate it due to the range of the data we cannot figure out. So we can only estimate it.
Actually, okay, we do not know the exact value of the population parameter. Is it a constant or a variables? Nào, nó là một cái constant hay là nó là một cái variable? Giá trị của nó là không đổi hay là giá trị của nó thay đổi ạ?
Không đổi ạ?
Yeah, không đổi, vậy thì nó là constant. Yeah?
Yes.
Yeah, it is constant. Population parameter are constant number. Okay, although we do not know the exact value of the population, the value of them are constant. Okay, we just don't know. All right. How about sample statistic? Is it constant or it varies across different sample?
It is very different across different sample.
And it means that the sample statistic okay, vary. We can say that sample statistics, we can what is it, random. All right, we call it random. All right, and what else? We can calculate sample statistic, and sample statistic is the
samples.
What is the relationship between them?
Between sample statistics and parameter.
Yeah.
Wait a minute. Yes.
We use sample statistic
to estimate the population parameter.
Yeah, exactly. We use the sample statistic to estimate, right? Estimate the population parameters, and in our model, are the population parameters in our model?
B0 and B1.
Yeah, the beta. Our parameters in the model are the betas. Okay. And what is the sample statistic? What are the sample statistic in our model?
Beta 0 hat and beta 1 hat.
Yeah, the beta hat. Okay, the beta hat. That is the sample statistic and parameters. Okay, thank you, Minh. Right. Rồi, các bạn, any other questions regarding those concept? Okay, được rồi ạ. Cảm ơn các bạn. Thank you. If we do not have any questions, we will move to exercise 2. Exercise 2. Okay. OLS estimation method. Okay, now we will have 5 more minutes to think about the questions, and then I will call someone to answer them. Okay, firstly, I will have to take the class list. Now think about exercise 2. Two, nine, 10, mm, mm, Okay, so anyone can help me to answer the questions for questions about it. So all three questions in the exercise 2. Anyone? It's short, then you can answer all three questions in the exercise 2. Okay. Hà có điểm chưa?
I think I haven't got any bonus points. So, here's my answer.
Yeah.
The criterion to identify the sample.
First one. Yeah.
Okay. So the first criterion is that it passes through the mean of x and mean of y.
Okay, wait a minute. That is the properties of the sample regression line. Okay, drawn by the as estimation method. But what is the criterion that we use to choose the sample regression model in the first place?
So.
Yeah.
So I think the first criterion is that the sample shares some sort of characteristics.
To identify the sample regression model, not to choose the sample, to choose the sample regression line. Okay, what is the criterion? We can have many, we have a lot of lines in the coordinate system. Okay, we can have a variety of lines in the coordinate system. So why do you choose that regression line? Why do you choose that?
So, as far as I'm concerned, we base this on the previous studies and researches in order to identify the sample regression model. But then
but that is
it depends on the theory that we choose.
Oh, the theory will help you to identify the population regression model, okay? And the form of the sample regression model will be the same as the form of the population regression model. But we concern with a certain line in the coordinate system based on previous series, you just can identify the form of the population regression model and corresponding sample regression model. Is this a line or is this a curve or something like that? Okay, but we do not know which line or which curve it is. All right. But when we have the sample data in hand, we can identify exactly the line, which line in the coordinate system. Okay, tức là chúng ta có thể xác định được đó là cái đường nào với các cái theories và các cái previous researches thì các bạn chỉ biết được cái form của nó có dạng như thế nào thôi, được chưa? Còn cái ở đây là với cái OLS estimation method thì các bạn có thể xác định được nó là đường nào ở trên cái hệ trục tọa độ của chúng ta, được chưa? Đó, vậy thì với cái OLS estimation thì cái criterion, cái tiêu chí để lựa chọn cái đường đó nó là gì ạ?
The sum of residue square is minimum.
Yeah, that is criterion. Chúng ta chọn cái đường sample regression model này đó mà nó làm sao ạ? Nó minimize cái khoảng cách, đúng không ạ? Cái khoảng cách giữa cái actual value và cái fitted value ở trên cái sample regression line, đúng không ạ? Cái đường sample regression line nào mà nó minimize được cái sum of square residuals đó thì nó sẽ chính là cái đường sample regression line mà chúng ta lựa chọn, được chưa? So the criterion here, okay, the criterions to choose the sample regression model with the OLS estimation method. We have the criterion to choose the sample regression model is that the sum of all residual square is minimum. Okay, that is our criterion to choose the sample regression model by using the OLS estimation method. All right, that is question A. Very simple. Okay, and what about questions B?
So the assumptions of the OLS, there are 7 basic assumptions.
Yeah, and what are they?
The first is that the function is linear in parameters.
Your signal is not so good. Các bạn thấy tiếng của cô có bị giật không?
A little bit.
Okay, đợi cô một chút để cô di chuyển cái wifi nhé. Okay, I think it will be better now. Okay, so what are the basic assumptions of the classical linear regression model? Or we can call it the basic assumption of the OLS estimation model.
So the first assumption is that the parameters are linear.
The model, the regression model is linear in the parameters. Okay.
Parameters.
And what is the second one?
Is that the residuals and the estimator of x and y are uncorrelated.
No, we are talking about the characteristic, the basic assumptions. Sorry, we are talking about the basic assumption of the OLS estimate for the population regression model. Okay, and there will be no residuals here. What is the second basic assumption?
I don't know how to demonstrate this. So basically, it can imply it can be implied that the x values are repeated with the same sampling. That means the expected the estimator of the estimator of UI and XI are uncorrelated.
Okay. Yeah. The estimator of UIN
XI
okay.
Are uncorrelated. Yes. That's what I meant.
Okay. So the second assumption here is just simply the x value variables or the independent variables are fixed in repeated sampling, which means that their value are known to us. Okay, they are fixed value, known value. Okay, so that is the second assumption. That is about the independent variables. And what is the third assumption?
The third assumption is that the conditional expected value of the disturbance is unknown. The conditional expected value of UI is unknown.
Yeah, the conditional expected value of the disturbance UI. What is it? What is the assumption about it?
Yeah, it is unknown. It is 0.
It is 0, not unknown. Unknown is different from 0. Okay, so here the assumption is that the conditional expected value of the disturbance UI is equal to 0. All right, that is the third assumption. And what about the fourth assumption?
The variance of the disturbance is homoscedasticity, or there are all the variants are equal.
So we have a homoscedasticity. Okay, we have the situation of homoscedasticity, which means that we have constant variance of the disturbance UI. Okay, all right. And the fifth one.
The fifth one is that there are no correlation between disturbances.
Okay, there's no correlation between the disturbance. Okay, and the value and the value of the disturbance in one observation is uncorrelated, okay, from the disturbance of another observation. All right, and what about the next one?
The final one is that the model is correctly specified.
Yeah, the model is correctly specified. And do you have any other assumptions? What do you say we have assignment?
Actually, there are, but we do not actually use them right now. Is that the number of observations must be larger than the number of parameters estimated.
Yeah, we still have some more additional assumption of the classical linear regression model, but because they are easy to match, okay, they are easy to match, so that we do not need to mention here, okay. All right, so that are some basic assumption of the classical linear regression model, or we could call it the basic assumption of the OLS estimation method. Okay, and for question C, what will be the characteristics of the OLS estimators if our model meet the requirement?
The characteristic of the OLS model, if we meet the assumptions, is that it's going to be blue. It means the best linear unbiased estimate.
Yeah, thank you. So when our model satisfies the assumption of the OLS estimation method, the OLS estimators for the model will be blue, which means they are best linear unbiased estimators. Okay, they are a linear function of the random variable y. They are unbiased estimators of the parameters of the population parameters, and also they have the smallest variable, yeah, among the class of linear unbiased linear estimators. Okay, all right, that are the best characteristic of an estimator that we want an estimator to have. Okay, but remember that those best characteristic can only be our OLS estimators can only have those characteristic if our model satisfies the assumption of the classical linear regression model. Okay, any question here? Okay, no. All right, so let's take a break. Okay, we will take a 20 minutes break and then we will come back and do the next one. That is question exercise 3. Okay, now take a break. Hello there. Have you come back yet?
Yes.
Okay, good. All right. So we have just finished exercise 1 and 2, and now the exercise 3. Anyone? Any volunteer? Okay, we see Quỳnh Anh now.
Yes, I'm here.
Okay, can you do exercise 3?
Yes.
Okay.
To measure the precision of the OLS estimators, we use variance and standard deviation of OLS estimators.
Okay. All right. So to measure the precision of the OLS estimator, we can use the the variance or the standard deviation of the OLS estimators. Okay. And the second questions, what are the factors that affect the precision of the OLS estimators of a two-variable regression model?
There are 3 factors that affect the precision. They are sigma in the sample size and the sum of x more I square.
All right. So we have 3 factors. Say that we have 3 factors that affect the precisions of the OLS estimators. The first one is the variance, right? The variance of the disturbance UI. Okay, which is sigma square. All right, sigma square. And how does the variance of the disturbance UI affect the precision of OLS estimators?
The higher the value of the variance of disturbance UI, the less precise. The less precise.
Okay, so the higher value of the variance of the disturbance UI, we have higher value of the variance of the OLS estimators. Okay, and which mean that our OLS estimators are less precise. Okay. All right. Now, what are the second factors? What is the second factors?
The second factor is the size of the sample.
Okay, that is the sample size. The sample size n. Okay, so how does n affect the precision of the OLS estimators?
The larger the sample size is, the lower the value of variance and more precise.
Yeah, we have more precise estimators. Okay, and the third one
is the sum of
yeah.
xi more square.
Okay. Yeah. Okay. So it is the variance. Okay, the variation in the value, the variation of of the independent variable x. Okay, this is the variation of x in the sample, okay? In the sample only. That is square, the sum of all square small x, right?
Yes.
Okay. And how does this affect the precision of OLS estimators?
When the variation increases, the precision, they are more precise.
Yeah, we have smaller value of the variance of the OLS estimators, and which mean that we have more precise, yeah, more precise OLS estimators. Right. Okay, thank you. So there are three factors that affect the precision of OLS estimators. Okay, and all right, we use the variance or the standard deviation to measure the precisions of OLS estimators. Okay, thank you. That is questions 3, exercise 3. Okay, Quỳnh Anh đúng không ạ? Quỳnh Anh. All right, thank you. And what about exercise 4? Exercise 4 is a calculation exercise. All right, so researchers would like to estimate FTU students' GPA based on the hours they spent on the internet. A random sample of data, including 10 observations, is collected and shown in the table here. Okay, the first one I then specified the model showing the dependencies of GPA on the number of hours students spent on the internet, and what is your expectation about the sign of the slope, and explain your reason. Okay, questions 2 and 3. Now, do this. Exercise 4. You will have, okay, for calculation exercise, you will have about 10 minutes to do it. Okay, then I will call a student to help me solve the problems. Right? Okay, for questions for exercise 4, any volunteer?
Can I say?
Who are you?
Nguyễn Thị Khánh Ly ạ.
Okay, Nguyễn Thị Khánh Ly. Right. Được ạ. Now, Khánh Ly. What about questions 1?
First, GPA will be the dependent variable.
Yeah, so GPA is the dependent variables, okay? And
the hours will be independent variable.
okay, so the number of online hour will be the independent variable. Okay.
So we will have the population regression function.
Yeah. What is it?
GPA equal beta 0 plus beta 1
plus beta 1
time hours I.
Okay, and hours. Sorry. Oops. Wait a minute.
Plus UI.
Hours. I and plus UI. Okay.
Yeah.
And what is the questions? Yeah. What is your expectation about the sign of the slope?
I think the side of the slope is positive.
Positive sign.
Yes. I think the higher GPA, higher the amount of time students spend on studying, the higher GPA they will get.
Actually, here is the hour spent on the internet for. Okay, it's not so clear here, but it's the hour they spend on the internet for recreation activity.
So I think it's going to be negative.
Okay, so it's possibly positive or negative. Okay, negative sign. So explain your reason.
I think when there is more, they spend more time in internet, they will be distracted by many things, so they cannot focus on studying.
Yeah, so the mechanism here is that as they spend more time on the internet for creation activities, then they will have less time for study, right? And it's possibly that the GPA will be lower, all right? That is the mechanism. And you can also find some more research to support your idea, all right? So that is our explanation for the expectation of the sign of the slope, for the negative sign of the slope. Okay, thank you. Thank you, Khánh Ly.
Yes.
Nguyễn Thị Khánh Ly đúng không ạ?
Dạ vâng ạ.
All right. For questions 2 and 3, 2 and 3 is a combination. Okay, so I see a lot of volunteer here. So Tobias, are you there?
Yes.
Yeah. Can
Okay.
you? Yeah.
So first I calculated.
Yep.
Sorry. The mean of x, which is 3.
Yeah. What is the? Wait a minute. All right. Now for questions 2 of exercise 4, What are your calculation?
First, I calculated the mean of x, which
Okay,
is equal
the sample mean of x. What is it?
to 3.8.
3.8.
And then the sample mean of y is 8.104.
8.104, right?
Then I calculated the sum of yi times xi, which is 304.
Yeah.
And then the sum of xi to the power of 2 is 164.
What? 164?
Yes.
Yeah. Okay.
And then I calculated beta 1.
Beta 1 hat.
Yes, beta 1 hat.
Yeah. What is it?
It's 304 mine. I shall tell you the result of the calculation.
Yeah. Okay, you can just write the result.
Okay, it's minus 0.202.
Is it? Minus 0.202, is it?
Yes.
Yeah, okay. And what about 0 hat?
It's 8.872.
872. All right. And then what is the sample regression model?
It is yi equals 8.872 plus minus 0.2.
So plus and minus will be minus.
Yeah.
Okay, 0.202
times xi plus ui hat.
Okay. All right. And we can also write as the sample regression function. Okay. But here, please replace yi by GPA and xi by hours, the names of the variables that we use here. We will have a GPA, right? Instead of using y and x, you can use the names of the variables that is provided here. Okay, GPA equal 8.872 minus 0.202 times hours. Okay, plus ui hat. Is this okay?
Yes.
Yeah, okay. And now explain the meaning of the estimated slope. So we have the estimated slope here is beta 1 hat equal minus 0.202. And what does it suggest?
Still me or someone else? Shall I answer it or someone else?
Yeah, you can explain it. Now try to explain it. Okay,
So
try to explain the meaning of the estimated slope. You can answer both question 2 and 3. Okay, try it.
It's a negative slope, so the relationship is negative. That means more hours are spent on the internet, the lower the GPI will be, and vice versa.
Yeah, okay. All right. So because the slope has a negative sign, which means that the more hour we spend on the internet, the lower the GPA. Okay. And specifically, okay, when a student, when student spend 1 more hour on the internet, okay, their GPA will decrease by 0.202 point. What is it? On average. Okay. Is this clear enough?
Yes.
Okay. All right. So this is the meaning. Okay. This is the meaning of the estimated slope. Okay. We estimated the value of the slope, and we get the result of minus 0.202, and the number minus 0.202 suggests that when the students spend 1 more hours on the internet, that GPA will decrease by 0.202 points on average. Okay, so thank you, Tobias. Class, do you have the same? Do you get the same result?
Yes.
Yes.
Yes. Okay, thank you. We still have one more exercise, that is exercise 5. Okay, and this one you will have to use data to solve the problems. Have I instruct you how to use data to estimate the model?
No.
Not yet. Okay. All right. So for this one, you have to use the data file named wage. All right. On the folder. Okay. We have the folder here. Okay. We have the wage file here. All right. And you will have to use it to do exercise 5. Now, first, you have to use data to estimate the model. Okay, now look at so this is the interface of Stata. Just wait a minute. All right, now just have a look. Have a look at our data here. Where is it? Oh, okay, it's here. All right, so this is our data. We have a lot of observation here. We have, how many observations do we have? Oh, we have 936 observations on totals. So if we do the calculation like we do in the exercise, exercise 4, it will take plenty of times. So that's why we will use the support of Stata to estimate this model. Now, firstly, this is Stata. Okay, this is the interface of Stata. We have some windows here. We have this, the result window. So when you type a command, this is the command windows. And if you want Stata to do anything, you just type the command here and press enter. Then Stata will do the command, and the result will be expressed in here. Okay, all right. This one is the review window, and all the commands that you have made in this session will be shown in this column. And we have the window of variables here. Right now, we do not have any data in Stata. That's why we have no variables here. Now, in order to regress the dependent variables on the independent variables, the first step is to import, okay, to have to import the data into Stata. We have 2 ways to import data into Stata. The first one, very easy. You just have to copy, okay, You just have to copy the data from Excel and paste it. Do you see the icon data editor here? Okay, we have data editor and we click to that. All right. And here you just have to paste the data that you have just copied. Okay, Control V. So a dialog is shown here. We have two options. The first one is to treat the row as data, and the second one is to treat the first row as variable names. So look at the data that you have just copied. Okay, so the first row, okay, the first row is the variable names. Is this correct? All right. Then in starter, you will choose the the second option, treat first row as variable names. Okay. All right. So all the data is imported, okay, into Stata now. Now look at this is the main interface of Stata, and look at the variable windows. You will see that we have many variables here. Okay, a lot of variables here. Actually, we have 11 variables in the data set. Okay, that is the first way to import the data. We still have another way. Okay, now before doing the second way of inputting the data, I will have to clear the current data that I have just input. Now, the second way, you will go to File here. Okay, we have the option of import. Now, you can import the data in many format, in different format, and you can use Excel spreadsheet. That is the most common way to store data. All right, we choose Excel spreadsheet. And now a dialog is open here. We will click to browse and show Stata where you put your data. All right, here I have, I put my data file in the desktop. Okay, and remember that the link that lead to the file must not have any special character, must not have any Vietnamese characters like the hat or the accent or something like that. Okay, all right, and then opened. All right, now you can if you have different worksheet in the Excel file, you can choose different worksheet here. Okay, you can also choose the cell range that you input the data. Okay, for example, I just want to input how many? For example, 20 first, the first 20 observation here. So I will choose the range from here to here. Okay, and we will change the cells range here. All right, you can change the cell range here from column A row 1 to column C row for example row, what is it, okay, row 21, for example, if you want to choose the first 20 observations, and then click OK. We have two options here, import first row as variable names. So, all right, the first row is the variable names, so click here. The second option is to import all data as string. String is not a number. If you import the data as string, you cannot regress the model. That's why do not click into the option. Then click OK. Okay, so we will have the variable here. All right, you can look at the variable by click to the data editor here, or okay, yeah, this is our data. All right, now as we have import the data into Stata, we can do we can write the command now. You can do what statistical description. You can also do a regression analysis. You can also do correlation analysis and everything and many other things. Okay. Now, for regression, we will use the command, which is reg, which stand for regression. Okay, reg, then space, then the name of the dependent variables. Okay, space, and the list of independent variables. All right. So here, for exercise 5, we want to regress weight on the years of educations. Then we will use the command, which is reg weight and space edu. Okay, now let's try it. Okay, now click into the command windows and type reg or regress is also possible. Now we want the dependent variables. Move your mouse to the variable names here and click on the arrow. Okay, and the name will appear in the command window. Now reg weight on edu. Right, you see that? Now remember that Stata differentiate between the uppercase and lowercase. So if your variable is written in uppercase, you cannot type the lowercase letter here. If your variable is written in lowercase letters, so you cannot type the uppercase letter here. Okay, so remember that. All right, and then press enter. All right, you will get the estimation output here. I will show it in Word so that you can see it more clearly. Okay, this is our estimation output. Okay, we have the estimation output from Stata. We have some table here. Okay, the first one, this one, the first one here is the ANOVA table. ANOVA here is the notation for analysis of variation. Okay, and it will tell you the variation, the total variation in the value of the dependent variables and also the source of variation. All right, so look at this. These are the source of variation in the value of the dependent variables. This row is for the total variation, and this one we have two sources of the variation. One is from the factor inside the model. Okay, that is the independent variables, and the second one is because the variation due to residuals, due to other factors. Okay, so here we have two sources of the variation. In the second column here, we have SS, which stands for sum of square. Sum of square. For example, this one is the sum of square, the variations that due to our model, due to the factor inside the model, which is the independent variables. So what is it? What is that value? What is it? We have learned this before. Okay, we have discussed this before. What is it? The variation in the variation in the value of the dependent variables that is due to the factors inside the model. That is due to our model. What is it?
ESS.
Yeah, that is ESS. This value is ESS. Okay, and this is the variation due to the residuals, and it is
RSS.
yeah, RSS. And what is it? This is the sum of ESS and RSS. It is the total variation in the value of the dependent variables, and it is
TNS.
yeah, TSS. All right. This column is the degree of freedoms of those sum of square. Okay, the degree of freedoms of those sum of square. Okay, what is the degree of freedoms for ESS? What is the degree of freedom for ESS?
1.
Yeah, in this case, for this model, it is 1, all right? But for the general case, we will have the degree of freedoms for ESS, which is K, okay? And K is the number of independent variables in the model. In this model, we have only one independent variable, which is the education. That's why K is equal to 1, all right? And what is the degree of freedoms of ISS? Do you remember it? We use this degree of freedoms when we calculate the variance of the residues. What is it? The degree of freedom of ISS.
I haven't found the degree of freedom just yet.
What is it? N minus K minus 1. Yeah, that is N minus K minus 1. In this example, in this exercise, we have N is equal to 935, okay? And K is equal to 1. That's why we have N minus K minus 1 is equal to 933, okay? And what is the degree of freedom of TSS? What is it? TSS.
N minus 1.
Yeah, that's correct. N minus 1. All right. Okay, so this column is the mean square, which means that you take the sum of square divided by the degree of freedoms, you will get the mean square here. Okay, just take this one divided by this one, you will get this one. This one divided by this one, you will get this one. Okay, and so what is it? What is this one? What is it? RSS divided by N minus K minus 1. What is it? RSS divided by N minus K minus 1. What is it? It is the variance of
Residual.
yeah, it is the variance of the residuals, and we denoted it as sigma square hat, right? Sigma square hat, this one. All right, and what about this one? This one is the variance of the sample variance of the dependent variable. Yeah, this one is the sample variance of the dependent variables. Here we have the number of observation, which is n equal 935. We have r square here is the coefficient of determination. Okay, this one we have not discussed in our lesson yet. This one is the same. Okay, and root MSE here, okay, is the model standard error, which is sigma hat. Okay, sigma hat, and okay, is the square root of this one. All right. In the lower table, we have the estimated model. Okay, here is the dependent variables. Dependent variables of the model will always be here. Okay, and in the lower round, we have the independent variables of the model. In this case, we have only one independent variables, that is HU, right? What is this round for? What is this round for?
Constant value.
That is for the constant or the intercept. Okay, this round is for the constant or the intercept, and this round is for the coefficient associated with these independent variables. Okay, we have here the first column is the coefficient, which means that they are the estimated coefficient of the model. This one is the estimated coefficient associated with the independent variables, that is beta 1 hat. Okay, this one is the estimated coefficient with of the intercept, right? So that is beta 0 hat. Okay, this column stands for the standard error of the estimated coefficient, which is SE of the beta hat. Okay, this one is the SE of beta 1 hat. And this one is the SE standard error of beta 0 hat. Okay, this column we have not discussed yet, so we will not talk about it here. Now you have just know some number. You have just find out the meaning of some number in the table. You can do the exercise 5 already. Okay, now at home, we will end the lecture here. And at home, please do the regression in Stata again. And remember the number here, the meaning of the number in the table. Okay, what does it tell you about the model, about the sample regression model and something like this? Okay, and do exercise 5. Okay, any questions here? No? Okay, so our lecture ends here. Goodbye and see you again on Friday. Okay.
Goodbye, teacher.
Yeah, goodbye.
Goodbye, teacher. Goodbye, teacher.
Bye bye.
Hey, goodbye, teacher.
Have a nice day.